The topic today is set builder notation. Before we talk about set builder notation, we need to talk about the number systems, and you may recognize this from grade 9. We have a number line. A real number is any number that can be written on a real number line. There are two broad sets of real numbers. They are rational and irrational numbers. Rational numbers can be written as a fraction a on b, where both a and b are integers. Here's our first set, the set of rational numbers. As I mentioned here, we can write all of these numbers as fractions. For example, 0.9 could be written as 9 on 10. 3 could be written as 6 on 2. 12% is 12 on 100, for example. Let's erase that. So those are the rational numbers, and we use the symbol Q for rational numbers here. The other set are irrational numbers, and you're familiar with these ones as well. Pi, 3.14159, which is a non-repeating decimal. E is Euler's number, 2.71828, again non-repeating decimal. A surd from grade 9, root 3, 1.73205, and on and on and on. 1 minus root 2 is the same. Okay, so these are irrational numbers, and the symbol we use is Q prime. That means not Q, not rational number, so irrational number. Okay, so from the rational numbers, we can identify the integers as a subset. Integers are whole numbers, such as 0, 12, minus 2, 3, 1, minus 3. They are whole numbers, and they can be positive or negative, including 0. From that set, we can identify the natural numbers, 1, 3, 12. Natural numbers are from 1 to infinity. Okay, no 0 and no negative numbers. Set builder notation. Sometimes it's more convenient to use symbols to represent sets of numbers rather than listing all of the elements in roster form or writing a sentence. This is an example of set builder form. We start by giving the set a name. Set A equals X such that 2 is less than X and X is less than 7. That basically means that X is any number between 2 and 7. But we look at the kind of number, integer. Okay, so as a sentence, we would say, write down the values of X such that X is between 2 and 7 and X is an integer. So in roster form, that would be written down here. They would be the numbers 3, 4, 5, and 6. Notice how we don't include 2 because there is no equal sign here, less than or equal to. So 2 is not included in this set in the same way that we don't include 7 in the set here. If we have equal sign here and here, we would include 2 and we would include 7 into the set there as well. Here are examples of how we write down the elements from a set when we're given the set builder form. So let's start by writing the name of the set P. This is telling us to write down the integers that are between minus 3 and 2. And we write down those values of X here. So the first element would be minus 2, minus 1, 0, and 1. Only the integers. So the cardinal number would be 4. There are 4 elements. In set Q, we are looking for natural numbers between 4 and 9 first. So that would be 5, 6, 7, and 8. So these are the natural numbers between 4 and 9. But this tells us to write the value 2x. These are the x values here. So our set would be 2 times 5, 10. 2 times 6, 12. 2 times 7, 14. 2 times 8, 16. In this question, also let's not forget the cardinal number. So there are 4 elements in set Q. In this question, we write down the natural numbers, so n. Now notice here we've got x and n. This is called a dummy variable, which we'll talk about more later. So the natural numbers are 1, 2, 3. Okay, so those are the n values. But we're saying that x is equal to n plus 3. So the first value is 1. So we write down 1 plus 3, which is 4. 2 plus 3, which is 5. 3 plus 3, which is 6, and so on. So we can't write the cardinal number for this set because it's an infinite set, which we'll learn about the next lesson. Okay, no cardinal number for that one. Okay, this question, look at the kind of numbers, integers. The integers between -3 and 2, including -3 and 2. So they would be -3, -2, -1, 0, 1, and 2. But we are asked to write down the value x cubed. So we write down each of these numbers cubed. So -3 cubed, -27, -8, -1 cubed is -1, 0 cubed, 0, 1 cubed, 1, 2 cubed, 8. Okay, let's do some more examples of writing down the elements. In this question, consider the kind of number, positive integers, which is actually the same as the natural numbers. 1, 2, 3, 4, and so on. And the restriction here is that 5 times the number must be less than 22. So we write down the set. The first number is 1. 5 ones are 5. Is that less than 22? Yes. So we write down the numbers. 1. 5 twos are 10. Is that less than 22? Yes. So 2 works. 3 works. 5 fours are 20. 5 fives are 25 is too large. So stop there. So the cardinal number of A is 4. There are 4 elements. In this question, we are interested in the prime numbers, and this is your restriction. 2 times the prime number must be less than 20. So the prime numbers are what? 2, 3, 5, 7, 11, 13, and so on. So set B. Which numbers satisfy this restriction? 2 times 2 is 4, less than 20, yes, so 2. 2 3s are 6. Is that less than 20? Yes. 5 is good. 2 7s are 14. Good. But 2 11s are 22. So these would not be used. We only go up to 7. So the cardinal number of B is 4. In question C, we're looking at natural numbers. So 1, 2, 3, and so on. Our restriction: the square root of the number must be less than or equal to 3. So what numbers could they be? What's the square root of 1? 1. Is that less than or equal to 3? Yes. Square root 2, that's less than 3. Square root 3 is less than 3. And go up until 9. Because square root 10 would be more than 3. The cardinal number then is 9 elements. In this question, you will see we have an equation, quadratic equation, and when you see equations, you will normally need to solve them. This quadratic will factorize x plus 2, x plus 3 equals 0. So x must equal minus 2 and minus 3. So the set is minus 2 and minus 3. They're the solutions to the equation. And the cardinal number is 2 because there are 2 elements. Okay, in this section we'll give some examples of how to write our sets in set builder form. Okay, here's the first question as a basic example. Write the set A of the first 5 natural numbers in both roster form and set builder form. Okay, in roster form it's quite simple. We just list out the first 5 natural numbers, 1, 2, 3, 4, 5. In set builder form, we think, how can we do this? We're told that they're natural numbers, so you know you need to put this section in at the back. And we want to write down the x values such that x is less than or equal to 5. And because they're natural numbers, we know they are from 1, 2, 3, 4, 5. And so you should get the same answer as this. This question, you do not need to write this. You can do, it's still correct, but because these are natural numbers, we know we cannot be less than 1. Okay, so this is adequate. X is less than or equal to 5, and we're saying they're natural numbers, so they cannot be 0 or negative. Okay. Okay, when you're doing these questions, think about patterns. Notice in this question, 3, 6, 9, 12. These are multiples of 3. Okay, so we can do our set builder form as 3x as the starting number, such that one less than or equal to x less than or equal to up until 4, because 3 4s are 12. And x is, we can use either natural or integers, it doesn't matter. Let's call it n. Okay, so the natural numbers such that x is between 1 and 4, and we write down the value 3x. Okay, I always use 3x here for this kind of question when we do multiples. If it's multiples of 4, we would write 4x. Okay, looking at this question, we don't really see any pattern. But what I recognize is that these are factors of what number? Can you see that these are all factors of 12 and there's none missing, they're all there. So there's no real formula that you can write for this question. So we're just going to have to use the word factors. Be x such that x is a factor of 12. And you don't need to tell the kind of number. We know they're factors. So you don't have to say they're integer or natural numbers. That's enough. In this question, you will see also a pattern. Can you see what it is? And think about it. 1 squared is 1. 2 squared is 4. 3 squared is 9. Can you see the pattern? It's a square pattern. So because you recognize the pattern, we can write down the set. X squared such that x is between 1 and 5, and we include them. And we could say x is an integer for this one, or natural number. Okay, so the first integer, 1. 1 squared is 1. 2. 2 squared is 4. 3. 3 squared is 9, and so on. So this is one way to do it. You may think of other ways that work. If you think of a different way, you check it by checking the numbers are actually correct when you double check your working. These here, you can just see these are integers. So D is x such that x is between -3, and they're all there up until 4. And x is an integer, z. Here are some more examples of how to write your sets in set builder form. Okay, in this set, you can see the pattern is prime numbers. So straightforward, set A, you write down x such that x is a prime number. And notice that the prime numbers are not stopped anywhere, so that is adequate. X such that x is a prime number. Question B, from the previous slide, you would see that these are factors of 48. So set B, x such that x is a factor of 48. Okay. No need to write the kind of number. Factors of 48, we know what they are. In this question, notice we have multiples again. These are multiples of 7, but starting at 14. So C, because we have multiples of 7, start out with 7x. Let's do this a different way. We could write that as 7x such that 14, 7x, 98. That's another way you can write it as opposed to what we did on the last slide. And x is a natural number. We can use that. So that's one way that you can do that. Or integer as well. You can use integer there. In this question, this actually looks like we need a dummy variable. So let's let x equal 1 on n. So our set would be x such that x equals 1 on n, where n is a natural number. So when n is 1, 1 on 1 will give you 1. When n is 2, 1 on 2 is a half. When n is 3, 1 on 3, okay? You won't see this kind of question very often. I won't give too many like this because it's really not that simple, okay? Okay, so try the questions on the sheet and good luck. And if you have a question, you can ask me online or through Google Classroom, okay?